All right, once again, a warm welcome to today's webinar, How to Drive Sustainability Through Digitalization, organized by SGTech and Green Koncepts. Thank you for taking time out to join us. My name is Christine from SGTech, and I'll be your MC for the day. Just some quick housekeeping before we commence the program proper. This session will be recorded for archival and marketing purposes. SGTech may use some or all of the images or video in its screen publications, digital platform, and marketing channels. Recording will be made available post-webinar on SGTech website, and you may send in any questions via the Q&A feature at the bottom of the browser, and they will be addressed at the last segment, which is the panel discussion later. Today, we have an amazing lineup of speakers. As everyone is aware, changes in the workplace brought about by the pandemic is placing new demands on corporate real estate management in offices and in manufacturing shop floors. There will be sharing of how digitalization can help you with the facilities management. Without further ado, I'd like to invite Mr. Lau Shi Ho, the chairman of Smart Nation Chapter, to address the audience. Shi Ho, over to you, please.
Thanks, Christine. Hi, everyone. Next slide, please. Now, most of you are probably familiar with SGTech. If you want a one-liner, SGTech is the premier tech association in Singapore. We have about 1,000 corporate members. So definitely we are representing the industry voice. But today we are looking at our Smart Nation chapter within SGTech. So in fact, what you see in the infographics there are three main themes or initiatives that we are after. How can we make our nation even smarter? And mainly it's about involving the industry. We know we have a very smart government. I mean, they have a lot of plans, but how about working more closely with our industry together co-create a smarter nation? But of course, we must do our homework. We must have a very tightly knitted ecosystem. We are not just going to go out and say, hey, here are the 10 loose solutions, different ones doing their own things. And Smart Nation needs many solutions to come together. And that's what the chapter is for, to bring players together and we integrate our solutions so we have an end-to-end truly Smart Nation offering. Now, of course, then how do we get stronger in terms of our internationalization? If we build our brand based on Singapore's already outstanding Smart Nation plan, I think that gives us a platform to even go international. So that's really what Smart Nation is all about. Next slide, please. For Singapore, actually, the official start of our Smart Nation journey was 2014, when our Prime Minister Lee Hsien Loong announced that this is our vision. That's where the Smart Nation plan all came out. It's gone through a few iterations of that, but most interestingly is the latest iteration, which is in the next slide. And if you're looking at the next slide, you can see now it's not just about a smart nation. I think we all recognize it's important to be smart, but sustainability has now become a very key topic. So the most recent announcements about green, right? The Green Plan 2030. And one of these 6 initiatives that specifically it talks about greener infrastructure, greener building, and that's really what this topic, what we are here for this webinar for. So in fact, it's my pleasure to introduce Kenneth, who is one of our chapter members as well as Farizan, their partner. So we'll let you, so Christine, over back to you.
Thank you, Shi Ho. So in the next segment, we have a dialogue session between the two speakers. So firstly, let me introduce Kenneth, the founder and CEO of Green Koncepts, who is instrumental in charting the strategic direction of the company. Through his experience and training in the field of IT, communications, and engineering, and through technological innovation and keen business strategy, he has built a company that uses cloud computing for integrating building management to connect, analyze, and manage data in real time. From building management systems, sensors, meters, controllers, and other IoT devices to an interoperable platform, in recognition of his leadership and contribution to the urban sustainability field, Kenneth was honored as a 2014 World Cities Summit Young Leader, where he joins urban thought leaders worldwide to actively catalyze change in cities, help create and shape sustainable environments. The next speaker will be Ms. Farizan, the Senior Partner of Green Koncepts, an award-winning green building consultancy firm based in Singapore and Africa. She was the first woman who has been conferred the Green Advocate of the Year for BCA SGBC Green Building Individual Awards in 2015, a Sustainability Leadership Award launched to recognize industry leaders for outstanding contribution in the industry. Trained in both strategic and technical consulting, Farizan has more than 25 years of experience in sustainability, energy, and built environment. She's also a green knowledge partner on quantifying the value of sustainability for the Channel News Asia Luminary Award. Let us welcome Kenneth and Farizan. Over to both of you, please.
Thank you, Christine, and a very warm welcome to all of you who are attending today's session. And I will start off by maybe introducing a little bit about who we are, Green Koncepts, and what we do. But without further ado, let me share my slides and get this started off. So today's topic is about how to drive sustainability through digitalization, and obviously at the center of this is IoT. And what I'd like to do is to first very briefly define what IoT is, because there's always a lot of confusion over exactly what it means. But before I do that, just to introduce Green Koncepts, we are primarily an IoT software company specializing only in IoT, and our aim is to help these businesses digitalize, use the data that is collected from sensors, infuse that with artificial intelligence and machine learning to make smarter decisions. And how does this relate to sustainability? Because a lot of the sensor data that is collected is related to the built environment. This can then be used to control and to drive the efficiency of systems that are in our built environment to help make better decisions with regards to operating these built environment premises that we work in. So we were very early in the market as far as a cloud energy management solution back in 2011. So over the years, we've learned a lot about all the different challenges with regards to streaming data, collecting this, sending this to different types of networks, and essentially what we have now is a robust enterprise-grade software application that allows IoT to be realized immediately. So today's agenda is a little bit different in the sense that we will spend only a short period of time on PowerPoint slides, and then we're going to spend a bit more time talking about sustainability and how that is going to work through a dialogue session that will involve Farizan and myself, and then we'll have a panel Q&A session which is open to all of you. Okay, so what is IoT? Now, IoT is many things to different people, and the word itself is kind of strange. But if I look at Wikipedia's definition, it defines a network of physical objects or things that we know that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data. So the exchanging data portion includes bidirectional exchange, so you can not just read data, but you can also send commands so that you can manage remotely and you can have machine-to-machine communication. Okay, and this is all done over the internet. So this is about a collection of sensors that are connected together. And pretty much in our world right now, we are connected to each other everywhere. The world is very, very closely intertwined. Now, to look at IoT, we have to look at the value chain, and it's kind of a long value chain, and it starts with things. That's the T in the IoT. And these things include sensors, controllers, machines, anything that generates data or allows you to control. So in that sense, a TV is a thing, a light is a thing, a pump is a thing, a machine is a thing. And when you have many things that are in close proximity, you want to be able to connect them together through some kind of a local network. And this could be your Ethernet connection, where you plug an Ethernet connection in, so that would be an example of a wired connection, or it could also be Wi-Fi, in which case it's a wireless connection. So connecting things together can be achieved either through wired or wireless connection. And this forms the local network itself. Now, when you have many things that are connected together, you would need to have some kind of a computing platform. We call that a gateway, or an edge device. And this manages these things by reading data from the things, and also to manage the heartbeat and to relay commands that are sent from the user interface right through to the edge, and then to send these commands to the things itself. And this part, gateway's function, is about data acquisition and transmission of data back to the cloud. And of course, we always need our telcos to be able to have the backhaul comms. So this could be in the form of a fiber network, or it could be in the form of a SIM card. And with that, we can reach the cloud. Now, on the cloud, there are different service providers. There are the infrastructure providers like the Microsofts, the Azures, the AWS, the Ali Clouds, and they provide essentially your compute, memory, storage, and some services as well. But you also need applications that run on the cloud to store, process, provide security, to serve APIs, and that's the other key function that runs on the cloud. And then finally, you have the business application layer, which is the user interface, which is what people interact with. And this could come in the form of a web application, could be a mobile app, could be a business intelligence tool, or it could also be an AI or machine learning engine. And together, these 6 parts form the value chain for IoT. Okay, and where Green Koncepts plays is we make the green boxes, so we make the firmware or software that runs on the gateways to manage the devices, the applications on the cloud, and also front-end web and mobile application, as well as some machine learning and AI applications. So having defined the IoT value chain, I want to now very quickly look at some of the challenges that are faced by adopters for this solution. The first of which is to determine and to select the appropriate types of sensors. And we know that sensors provide a proxy for what is going on in the built environment. And there are different types, different brands, different ways of connecting it, and they provide different outcomes. So selecting sensors can be a major challenge, because if you have a particular use case and you don't find the right sensor, then you could make that mistake and then find that the data that you get doesn't really relate to what you need. The next step is the integration of these sensors into to acquire the data. Now, unlike our PC, which has a universal USB port or Bluetooth that can connect to multiple devices, in the world of IoT, unfortunately, there are no standards, and therefore each sensor has its own communication interface, it has its own protocols, it has its own way of addressing, and this poses a challenge in terms of acquiring that data. Now, once data is acquired, you would then still need to build the necessary infrastructure on the cloud, the application level, to store this data, stream this data, serve this data through APIs, add user management layers, metadata management, security, and this also poses a significant challenge. And not forgetting, we need the business application layer. So if you are talking about sustainability, then there will be an energy management piece. If we are talking about indoor air quality or occupancy management or temperature management, you might want to see this in different ways. And this essentially requires industry and domain knowledge. And then finally, we reach the holy grail, which is AI and data analytics. And essentially, if you don't structure and store this data properly, then you're going to spend 70% of your time cleaning it, trying to make sense of it. And when we're dealing with time series data, you also need integrity with regards to time stamping of data if you're going to cross-correlate them. And so these are your digitalization challenges that any large enterprise or any small company faces when they want to adopt IoT. And what we have done at Green Koncepts is we have developed a platform that solves all of these issues for you. Okay, we've made it basically a software as a service and a plug-and-play connectivity, whereby there is a gateway. And if for those of you who can see me on video, this is what the gateway looks like. This is my Samsung mobile phone, so you can see the relative sizes of these two items. And with a single gateway, basically, we make the firmware that runs on this, and this now has universal connectivity to thousands of different sensors, controllers, as well as third-party building management systems, PLCs. And the function of the gateway is to acquire that data and to relay commands that come from a user or from an AI engine so that we can effect changes in the actual environment itself. Okay? So with the gateway together with the cloud working together, we now have a platform that allows any sensor to be connected in very, very quickly. So we can onboard a new sensor and test that in a function of 2 to 3 days. And then you would now have connectivity and data streaming across through the APIs whenever you need it. And that's what the platform is. Now the platform has several key functions. So in the acquisition space, we support open protocols. We have a list of protocols that are already ready, and whenever you have a device that supports this protocol, it's almost a plug and play interface. To standardize data, we have to transform them. The world has no standardized units. Some people use degrees Celsius, some people use Fahrenheit, but we need to make sure that we have a consistent way of storing this data so that upstream applications know that it's in degrees Fahrenheit. So we've got transformation of data, naming conventions, units, data mapping to standardize this at the edge. Next comes the management function, which is when you deploy 500, 1,000, 5,000 devices, you must have the ability to know what's going on with them, to be able to manage them, access controls, user controls, hierarchies. How do we define metadata that defines where the sensor is located, what is it measuring, okay, so that upstream applications can filter, search, cross-correlate this based on metadata. And then we've got the storage function where streaming data, millions and millions of data points every minute are stored and served in real time. Storing configurations, reports, system logs, user logs, and everything that actually happens. And then finally, the layer that serves this data through open APIs. Now, we believe in open APIs, so any customer who wants to build their own app can do so. Any customer who wants to stream this data to a BI tool can do so. And this is all in that serve box in the API itself. And so these are the key functions of the platform. And as I mentioned earlier, out of the box, you get these APIs, and they are all in RESTful format. And data is pushed in real time. And historical data, you can request for it. And so this allows development and co-innovation of different applications that could be used in the market itself to drive sustainability and to support our Smart Nation initiative. We also connect to BI tools out of the box. So if you have a connector and you know SQL, you could immediately query and get this data near real time. And this includes both your BI tools that are popular in the market, and any one of them, as well as some of the machine learning tools that are popular with data scientists today, such as R or Python or any of those things. Okay, so the point here is that it is open and it is available to anybody who needs it. And just to wrap up my quick introduction to what we have, once we digitalize, what do you actually see on the application? So that's the important portion. So I'm just bringing up some of the key features of what we have. So you have an intuitive user interface, which basically has what we call a device card. It's a digital representation of a physical device itself, because we are digitalizing it. You get digital floor plans, so you know exactly where these sensors are. You have a mobile app that allows you to basically manage on the go, because one of the functions of digitalization is that you should be free to operate wherever you are and not be constrained to a particular location. And then for sustainability, you might want to compare multiple buildings, you might want to rank them, you might want to compare what they have. And then for energy management, which we will talk about a little bit more about today, you have the ability to look at data by building, by floor, by different types of loads, by certain KPIs, and you've got digitized floor plans, historical data, and everything else. And we've gone also another step to digitize our electricity network. So we have what we call power chain management, which gives you a real-time power distribution and demand network for your MSBs, subboards, electrical DBs, EDBs, and then you can see how power flows through the entire network with real-time power trip identification and visibility over how much power is being drawn. So this could be useful for, these are used by our data center customers and also for industrial customers where power is critical. And to complement the sustainability suite, we have air conditioning management. So you have a ducting plan of your building or office layout, and you see where your sensors are placed on these ducting plans. You can control your air conditioning, centralized air conditioning. You can change set point settings, operating set points. You can manage your VAVs, FCUs, AHUs, and do what you want to do for air conditioning. You could also drill down into a specific unit. In this case, it's an air handling unit to see detailed sensor data to analyze and identify opportunities for further optimization, or if there's a fault, you could basically access this information when working from home and to allow you to respond to these faults without ever having to step into the building itself. Okay. So just extending that a little bit, you could have centralized fault dashboards whereby every time a fault comes up, you get a notification on the real-time screen in real time, so that you can again manage remotely and track the status of all these faults to resolution. Last but not least, this is more an occupancy solution whereby we count how many people are in a particular space. And if it's full, we tell you how long you need to wait before someone else can come in. Okay, this is particularly useful for areas for safe management measures where we want to limit the number of people in a particular space. So in short, in summary, our platform supports 6 categories of solutions. The first is energy management, which is something that we will be talking about today. And this covers electrical, water, chill water, fuel, as well as your solar or renewables. We also have a suite of applications for air quality, and this is very, very hot right now because of the whole concern around health, and this measures all your different air quality parameters. And then we've got a group for intelligent controls, and this is primarily for lighting, air conditioning, and mechanical ventilation. Occupancy management, these are people counting, desk occupancy, and this is to support the whole return to work and the need to restrict the number of people and the booking of seats and desks to know how many people are in the office. So, and also a social distancing function in there as well. Data centers is another area that we focus on, so we can manage and track the infrastructure in the data center with power systems, server rooms, mission critical equipment, and everything else that is either in the building, in the office that's mission critical, or for IT assets. And last but not least is a predictive maintenance module that's targeted at what we call rotating equipment, pumps, motors, mission critical equipment that has to operate all the time. Civil infrastructure, like bridges, structural columns, to know actually what's the performance deterioration over time and whether structures are safe over 30 years, 50 years. So there are sensors for that, and there's a use case for that. And all of these is encompassed in a modular, flexible, scalable package with, that supports multiple locations, but yet it is integrated. So that's a very quick intro to what we have. And today we'll be focusing on energy management and intelligent controls. And specifically, I think we'll be looking at electrical, chill water, water, fuel, renewables, which is the sustainability part of today's discussion. So with that, I would like to pass this time to my co-speaker today, Farizan, who is a consultant who's been working to help our customers find means and ways to improve their sustainability, specifically energy management. So Farizan, please share with us what you do. I think you're muted, Farizan.
Yeah, coming. Hey, thanks, Kenneth. It was nice introduction. So it's an interesting world, and everything that what Kenneth has just brought about is actually very dynamic, very interesting, and it's therefore why we are actually having this discussion. So I'm just going to have 2 slides not about us. So we are a 12 years old company. We've been dealing with transformative sustainability in Singapore, in Asia, as well as in Africa. So we focus quite a fair bit on zero building certifications, as well as DG energy consultants in part of our scope of work. Just a good look of where we are globally. We have projects everywhere, but predominantly in Africa as well as in Asia. So the topic of today's discussion is to bring back a little bit about building monitoring system or building management system. This term is being coined sometime back in 1960s. Back then it was used quite, not a lot, but very little. And a lot of times it was tagged a lot with sophistication, used dominantly in large projects with extensive mechanical, HVAC and electrical systems. Back then, even if you have not noticed, there was a lot of savings in energy. They were just using BMS alone back then. We don't have the luxury of IoT back then. So everything was very much basic. But with that basicness, some of the BMS system can account up to 20% of building energy savings, which is very, very good. However, how should I say, over the period of time, people do feel that it's a sophisticated system, it's an expensive system. There's a lot of challenges back then in 1960s. So with today's current time, we have what we call the rise of the IoT, as what Kenneth has just explained. So the rise in the building management system that integrates the use of internet protocol. I think the key word here, right, is actually the open standards. The open standards has actually given us a lot more freedom, agility to what we can actually put onto the building, put onto system, and that makes it very creative, innovative, and explore. You can explore almost anything that you would like to monitor, anything that you like to measure. So the model-driven architecture use AI to drive smarter building outcomes, hence therefore that's where the savings in terms of energy, not just energy, but resources as well. So the point that is that used dominantly in large projects with extensive mechanical is no longer there. So very nice indeed that we can actually use it in almost all kinds of projects, you know, and in even homes, all types of buildings. We'll speak about it later on during the dialogue session. So the main key thing in the world of IoT, as what Kenneth also mentioned, it was literally the sensors. The sensors are the ones that pulls everything together. And sensors you can place in almost every varieties, every spaces that you like to have a control over, or you like to have a monitoring over. Again, we'll speak a little bit about the dialogue. So this is a little bit of a simple metrics, but we can do maintenance is what predictive maintenance, business operation to drive in the numbers to understand the data that you collect. That's business operational infrastructure in terms of measuring people, human traffic, leakages, buildings. So the building, why I circle the building is because the topic is so huge that I think we're just going to focus today on what building and IoT sensors can do within the building. I would like also to pause a little bit. I think this has a lot to do with our Smart Nation program as well. I mean, without which I think we would not be where we are now. The push is not as much. And also I have to bring into focus our 4th Green Building Master Plan, of which all the buildings are to reach super low energy by 2030, which is less than a decade from now. And how are we supposed to get there? How are we going to get the energy savings that we would like to target for? And how can we help to decarbonize Singapore as a whole? So generally, okay, in a building, you have the main thing, which is actually the building load. And within the building load, you have the building systems such as lights, air conditioning, etc. And you have other things such as buildings equipment, which is the machinery, the office. It depends whether you're industrial building or whether you are an office or residential, different typology. So all of this has one key thing. It's either what I predominantly term as ghost load or managed load. Ghost loads, simply put, are the things that you can't see, the things that is on standby most of the time, the things that's within a plug and you never switched off. Simple things are like your photocopy machine or like anything that's on standby that you don't actually switch off. Those are actually the ghost load. So ghost loads still have demand load, which means a lot of things are still being taken into the consumption. The ghost load. So the managed loads are the ones that we actually have most of the time that you can equate to, which is the lights, aircon, etc. So this particular circle here is where the IoT box comes in. So the IoT is all the sensors. You can actually go down to a box, as what Kenneth mentioned, and then it will be put back in to actually save energy. So save energy in terms of reducing the building load, but it can also be in the form of comfort, thermal lighting. It can also be in the form of controls to actually bring us to the lighting comfort or to the air conditioning comfort. So indirectly, it actually monitors the building load and bring it down. User behavior and monitoring is one of those other things. It could also be crowd sensing, and especially in today's COVID times, there's a lot more requirement of monitoring where people are, where places are, and what's actually happening within a certain space. So if you can notice, there's this line that I've actually drawn that crosses over to BMS. So to a certain extent, it can actually have a BMS. It can actually incorporate a BMS, or to a certain extent, it doesn't need to incorporate a BMS. We can talk about it later as to how complexity is subject to the size or what you would like to measure, what you would like to monitor, where it crosses over. Okay, so this slide is one of the simple slide, but it's a very important slide. It's a very important master slide. Based on the first top slide, these are the 4 parameters predominantly people ask. The size, the type, and the industry. We'll cover that later under the office, tenants, industrial or office building, large and big. Financials, the cost, that's one of the key areas of decision making, control models, and innovation. So predominantly, when do you actually think that the building should cross over the BMS? Before, as I said, in 1960s, most of the things are under BMS, but however, now a lot of things can be controlled within the IoT. But of course, to a certain extent, and when a building has a BMS is when you have a large industrial building, and then you can incorporate BMS. These two works harmoniously. For your information, it doesn't need to be separated. The financial model has changed significantly a lot through the years. And now we have software as a service, SaaS, versus a BMS, which is typically is a CAPEX driven model. And the control model. So literally, what's the threshold? What's the AI machine learning that you like to come up with? I would say last time we can't really do a lot, but now with like what kind of say with Pythons and all the other algorithms that we can actually put on board, we can control pretty much all of the buildings, machinery or all the building functions that we like to have. So the last part, which is actually very interesting, why is top and bottom arrow, is innovation. Okay, most of people feel that this item is complex. I do not know. I think in my line, most of the time, people, when I talk about BMS or IoT system, people think it's expensive and people think it's complex. And then they start to get worried, you know, why? I mean, how do we onboard this? It looks like it's so sophisticated and etc. But there's a lot of hidden pockets in terms of innovation. That's where we call it the Juga innovation, which is a Hindi word. Those are low-key innovations that can easily be deployed with sensors and APIs and put in a certain code function that you'll be able to actually harness the benefit and actually push the energy savings level to what it actually needed. Okay. So this is one of my last few slides before we go into the dialogue. Why we need IoT? Why we need IoT controls to drive sustainability? So in zero energy building or super low energy buildings, designers such as us or environment sustainable design consultants such as us, we can only do so much under paperwork design. So we always have a little bit of a gap that it depends on the operations, and operations are critical energy savings items, okay? So we have to monitor and we have to control. So we have finished part of we design, we plan, and then we let the building run, which is the operation side. The building cannot run as it is, and sometimes we humans make errors as well, and we need to tweak and we need to fine-tune certain things, and that's where the monitoring and the control comes in. So this monitoring and control has to be embedded right from the beginning when we actually design the building, and also it has to be from the beginning because we need to understand the building thoroughly and put in place those items so that the monitoring and control can be implemented when the building is actually in operation. So in short, it is actually to reach the last mile. So for example, when we design a building with, say, a platinum building with 35% energy savings, and as much as we can assume most of those assumptions will be left towards the last end where the building is running in operation, right? So that is when we need to reach that last mile to cross over. And that's when IoT's monitoring and controls comes in very, very important to that. And we also need the data information for decision. We need it for tracking and the ease of reporting. We need to track. We can't monitor, we can't track, we can't improve, we can't modify, we can't upgrade, we can't do a lot of things. So we need this data information. And I'm sure you know in today's world, data is one of the most precious, valuable information we can get. So those are the data information we need for decision making, not just now, but also in the future, to tell us rigidly where we should be going and what we should be doing. This data information is also super important now in emergency management. Back then, we don't have all this emergency management such as COVID. Now the buildings are operating at a level that I couldn't even believe, so low in that level. So do we have those controls to put in place that we can actually manage, track, monitor, and modify what we need to modify in terms of the buildings? So it's really, really actually required now for emergency management to have those items. The last one is quite interesting because I think over the years, I came across this thing which is done by George Bernard Shaw, one of the quotes by him. The single biggest problem in communication is that the illusion that he has taken place. So this has a lot to do with facilities management and all the rest, okay? Because every time, or even user, you tell people to switch off their lights, right? You tell people to switch off things, right? You communicate with them, but not necessarily that it actually absorbed and being implemented. It just disappears. But doesn't mean that you communicate. But however, with IoT sensors, at the very least, I have this form that, I communicate, but at least I got the barrier that it will actually act on. So the single biggest problem in communication is that the illusion, it has taken place. I have told you to switch on lights. I've told you to switch on something, and I expected you to do it. So I used to advocate so much on that, to say that you just keep on preaching. But to some degree, right, I needed assistance. And therefore, that's when IoT sensors, whole and behold, came into the picture. And I said, okay, fine, I had IoT sensors to actually lock down, put it this way, the most kiasu version of things that I can actually think about. And that's one of those things that can actually drive the energy savings further. And so therefore, this thing got stalling. And therefore, simply put, we need IoT to drive sustainability, as we cannot solely depend on defaulted methods of communicating, reporting, and the operation of the building if we are to achieve tangible, sustained results. Okay, the word here is sustained results, because to have things sustained, the loss of diminishing returns, where people get fatigued and they forget and stuff like that. So therefore, we need the IoT sensors to come in. So that's the end of my piece. Kenneth, Christine, I'll over to you.
Okay, thanks, Farizan. And I think I'm going to hand this time over to Christine, because we actually had a little poll prepared, but we kind of forget to do that. So Christine, do you want to now hand this time back to you, and then maybe we can run that poll before we start our dialogue session.
Sure. Thank you so much. Thanks, Kenneth. So as what Kenneth has mentioned, we will bring up some poll questions and let everyone answer. So please help to answer it. We'll leave it there for about 1 to 2 minutes. Thank you. There are a total of 4 questions. Yeah. Now I see responses coming in already. Thanks, everyone. Can we have more people to respond to the poll questions? We shall leave it there for another 30 more seconds. Thank you for those who have responded already. Thanks, I see more coming in. Okay, thank you very much, everyone who responded to the poll. So now let me hand the time back to Kenneth for the dialogue session together with Farizan. Over to you, Kenneth and Farizan.
Okay, thank you, Christine. So yeah, we wanted to keep the session, the presentation short, and instead to have this dialogue session where we can maybe tap a bit of Farizan's brains and experience regarding as a consultant to help businesses drive consultancy. So I have a first question for you, Farizan. What does sustainability actually mean for a business, and how is that different for a company that owns its own buildings? A tenant who rents an office space, like for example, someone whose office is in the CBD area, they rent a space to run their business. And for a manufacturer that owns a factory and produces things, for example, can you share with us how are these 3 scenarios different? And what is your advice for those who want to start?
Kenneth, your question is like the whole thing all buckled into one. Okay. So I think all of them share almost the same features, don't you think? I mean, like you share the same problem, the same fear in actual fact. The fact that how are you going to control the energy, right? What do you want to put in place to control the energy? All this fear, you know, as the bosses of a building or the owner of a building or the bosses of a manufacturing or industrial, they look at their bills all the time, right? And what they see? They see the graph just going up. like they just see the thing going up, but they can't really diagnose to the point, like why is it going up? Where is it going up? And they can't, it's very difficult because they can't get a grasp. So what they do is that they try to look for their facilities manager or their production operator and said that, what did you do something? Did you do something wrong? Did you actually run something? So these are the few things that is like an abyss, you do not know where you're going. So what they can actually do is try to set it into spaces, put it into different partitions and monitor it, because resource efficiency, resource means energy, water, material, spaces, occupants, all needs to be measured in that sense. So maybe you can tell me more about the items that you actually have experienced for such a building also.
Yeah, so I think referring back to Shihor's comment about how we have a green sustainability plan for 2030 and there's legislation that forces all businesses to reduce energy consumption and taking a cue from Farizan here, sounds like the first thing that needs to be done is to be able to measure, because if you can't measure, then you cannot manage. And then that's a question of how we can use digitalization and sensors to do this. So for us, digitalization is really the use of sensors to collect data about what is actually going on. So sensors represent a proxy for what is actually happening in the environment, what has happened today, yesterday, how energy has been used, for example. And then to use these data sets to either run data analytics against them so that we can tell a story, or to build smart AI engines that automatically make decisions for us. So that's how I see the first step in terms of the drive towards sustainability using digitalization.
Yeah, that's quite true. I have to bring this a little bit backwards, right? Like when you say AI, right? A lot of people in today's world, right, they get scared. AI, it's a fanciful word, it's a nice word. We all know machine learning and AI, what it does, right? Kind of. But maybe you can elaborate a little bit, right? In your definition, right? How does AI comes into practice? I would say that most of the information you need is from the building owner, right? From the building occupiers and etc. And then we give you so that you can do the machine learning part or the artificial intelligence part. But what do you need apart from the building owner? Is there anything else?
Right. So yeah. So firstly, we don't have to be afraid of AI. It's not like a Terminator movie kind of thing. It's basically a computer program that uses past patterns available in the data sets to help make sense of what's going on, and then you add decision making to it. Okay, and that decision making means that humans don't have to manually analyze this data. So we utilize computer programs to do that for you. But specifically in the area of sustainability, we will require information about how and when energy is used, what are the systems that are connected and that are consuming this energy. And then we need expertise to understand how to better operate these different types of equipment. And this is maybe your domain, Farizan. What can be done to optimize energy for air conditioning, lighting, and the different spaces itself?
Yeah, you can actually do a lot. I mean, from where I come from, right? What's the beautiful part about this IoT, right? You can implement it in just a single tenant office. You do not need the whole building. You can just start in your own office, be it 1,000 meters square or even less or more, you can start to do that. And those are easy to plug and place inside, it's no brainer in actual fact. And we'll talk about the why people are fearing it, because I think most of the time, right, people fear it because of the unknown, and also the fear of complexity. Complexity is that to them it's all digital, it's all connected, you see. So what if something happened? What if something dropped? What if there is a lot of ifs? But not putting that at all there's a lot more if. What if there's a lot more if, which means they would not be able to actually tell or report upwards or even make the decision that they need to make. Especially in COVID, how do you actually measure something to actually control something? You can't. There's so many things hidden. That's just an office area, right? Kind of. But if you go to a bigger buildings or industrial, it just gets worse in actual fact, because the place is too huge to actually go around asking people to go and get this data and that data. So that's why I would say that IoT plays a very, very important role in today's world to drive sustainability.
So, Fariza, let's talk about an office space, and I'm sure some of the members of our audience here basically work from offices. Let's say it's an office space in an office building. Let's, for example, say I have an office in Suntec City. Where do I start? What can I do to drive sustainability in my office?
Okay. I think sustainability in my mind has two, besides the resource efficiency, is also to do with indoor air quality. Before, we were talking a lot about PM 2.5, right? I don't know if you remember, we were talking about haze, and then you have haze, and how do you measure the indoor air quality of the haze? Now we have COVID. So all these things are what we call transparent. You can't see them, it's intangible. So how do you actually monitor? How do you know? So the only way is actually to put in the sensors to actually measure them. So thank God for that, the world invented sensors and more of them, right? That enable us to place them inside the transient spaces like lobbies, corridors, and also the offices. So sustainability has two connotations to me. One is resource, another one is health and well-being. So these two are equally important. Even noise decibels for near the roads spaces, you can do plentiful. But the main thing is that the person or the owner of the building needs to understand what is important for them to measure as well. Because, as consultants, we can only do, say, so much, like 80%, right? Somehow, what if that building owner decided to change the function of a space? It used to be an office, and then now it used to be a showroom. So how do you actually track that particular space further? How do you actually track the plug load management further, or ghost load? We call it plug load, ghost load, receptacle loads. It depends on which terms you actually use. So we need to enable those items inside. And once it's inside, you will be able to track it.
Okay, so for an office, the areas of focus that you just mentioned would be things like plug load management and the need to measure energy, indoor air quality, and then of course the other variable that an office space has is the lighting itself. Correct? Yeah. So what are the steps that, that someone in this area can? And we're looking at the resource side of things right now. What can they do?
Well, energy encompasses two things generally: aircon and lights. Those are the main two things, the aircon and the lights when I talk about energy. So the lights, you can do controls in terms of zoning controls. You don't want one light switch that opens up all the whole place, right? You like to do zoning. You like to have control over the lumens or the lux level that you actually used. You need to actually able to control the amount of daylight, and therefore the indoor artificial lighting is actually reduced. You need to control in terms of how much lighting consumption is used in that particular specific departments or categories or industrial spaces. So those are all the things that you have to do with lights. And now we've a lot more enablers to actually use. You do not need to put all wirings. You can put sensor circuiting to actually read each other. And therefore, you can actually connect all those into one particular control factor, and you can actually control it from your WhatsApp, from your phone software, your UI that you actually put it in. Aircon is a big chunk block there, because between the lights and the aircon, right, the aircons will take predominantly more than 30% of our whole. So if you take care of your aircon has a lot to do with temperature. So if your temperature, you can elevate. If you're the only one there, right, in the entire space of the aircon, in the entire space of the office, you do not need for it to be like at 22, 24, or even 25. You can actually make it higher. and what's the velocity of the air. All this can be controlled through the sensors. If you don't want to control the sensors, then you'll be able to have an automatic sensors. So automatic, which means you can design an autonomous building. You can design a self-run building, a building that literally can run by itself. Okay, and the only time you need to actually take care of it is when there is something that you need to change, like a light bulbs or service something. But apart from that, it should be self-run. I mean, even more in this COVID where we're having more of a labor in terms of challenge labor for facilities management. All of us has to reskill, so that's the way we should actually be heading to.
Okay, so sounds a bit like what we have, we're on the right track in terms of the solutions that we offer to our customers right now. Smart lighting, as you mentioned earlier, micro zoning it, and that's one of the ways. We've basically tested this in some of our customers where they have achieved about 30% energy savings just from being able to create micro zones in the office, and each zone has its own occupancy sensor to detect, for example, how many people, whether people are around, and if you're not around in the zone, then you can shut the lights off without any impact on your colleagues sitting in the next zone. And these things basically result in savings, because a lot of our time that we spend in office is we attend to meetings, we go out to meet customers, we come back, and we are not sitting in our space 100% of the time. So this is the lighting section as well. And for plug load management, what is your advice? How do you manage that?
It's very interesting. Plug load management, typically as a consultant, right, when we actually design a plug load, right, we have a few demand load. We typically put certain numbers there. But those are standby loads. Standby loads, which means you don't necessarily use it. You can switch it off. But like when I say about communication, right, you can switch it off. But the probability of you switching that off will be very, very, very slim. So that's why you need IoT sensors to assist us to switch off. I'll give you an example. We have this building that we work on, right? The building is running 24 hours. Apparently, it's not supposed to run 24 hours. It runs 24 hours because there's traders, there's brokers, there's people who are at night, which comes into the building. And it's not such a big building, but the energy consumption is so high. And so we don't understand why an office building running supposedly 9 to 5 has such a high consumption, right? One of the reasons is because those people who comes in, those traders, brokers, or people who comes in at night, they switch on the aircon, they switch on their lights, they switch on almost every single thing. And they don't want to switch it off. They just leave it there. So if you pass through the, especially you see one floor on, you just see one floor on. So those are the things that you will not be able to control, you'll not be able to see unless you're in the building or unless you're the security guard beside you. But you will be able to see it from your application, from the GUI that you actually set up. And he said that, oh, this level, and then you'll be able to trace also who came in, the last person who came in. And that will be able to even further trace in terms of the plug load management. What do you actually switch off? Which items is better than a timer, because timer, you have to put all these smaller things and then you have to actually manually do it. Now you don't have to do any of that. And for industrial, it's worse because you have big machines that's running, huge machines that is running. So how do you know whether your machine is running over its capacity? You need plug load management again to actually come into the picture. So I would say the benefit is endless to have it in place. So kind of in terms of like complications, right? What was the most like complex item that you feel that people misunderstood most of the time when they ask about IoT or sensors? Misunderstood, you know what I mean? Like every time they ask you a question, they kind of like don't quite understand why and how they need to get there.
So as I mentioned earlier, I think the value chain for IoT is fairly complicated. It starts with the selection of the appropriate sensors. And just for example, if we want to measure energy, so we have requests when people say, hey, you know, can I reduce the energy consumption of my photocopier machines, right? And you talk about the fact that they are not used most of the time now, especially when people are working from home. So the first thing that needs to be done is how do we measure energy from such a photocopier machine, for example. And again, I like simple things. So here I have with me, for those of you who can see, I have a smart plug basically, and basically what this smart plug does is it measures your energy and it allows you to turn something on and off. So what we have done is we have deployed this in office environments, and this controls photocopier machines, it controls water coolers, dispensers, and by integrating that onto the platform, our customers don't have to worry about the complexity. So basically it's plugged in, so you can see there's a 13 amp plug. Basically you plug that in and then you plug your equipment on top of the socket on the other side. You connect it to your system and now it's digitalized. So the next thing you do is you then create a schedule if you want to turn it on as fixed times. If not, you can link a sensor to it. And so if someone is present, then this piece of equipment that's connected is turned on. And so this simplifies the whole process, and it starts with being able to clearly identify what is it that you want to achieve, and then to deploy the appropriate sensors, which then it's all pre-integrated and it works. Yeah. So that's how to take away this fear or this concern about complexity. And these are cheap solutions. So the one I show you right now is off the shelf, okay? And we have integrated it onto the platform. So you just go to Challenger, you can buy one of those and you can connect that to the platform very easily. Yeah.
Yeah, you're right. You remember my last few slides when I talk about frugal innovation, which is Juga. So some of these things are like what you said, you know, it's easily to apply on. It's not that difficult. It just needs an effort to understand. I think understanding needs an effort. Because if you don't make an effort to understand, right, then you will never understand it. So you do need that effort to understand. Yeah.
Right. And so what we have done is we have, I mean, to help, we understand that this is a transformation for the industry, especially in the built environment, to digital, and it can be quite daunting for some parties. And to make it easier, I'm just going to share my screen right now so you can see one slide. We've actually built, we call it an IoT Experience Center, okay? And this IoT Experience Center effectively has many live sensors that are connected in like an experience environment, and we are getting many visitors who come to visit us to say, hey, you know, how does this connect together? How does this work? How do I make sure it's too complicated? And then they have a hands-on session when they visit us, whereby they can try, experience it, and then they realize that, hey, actually it's not so difficult. It's actually quite straightforward. And then the app shows you what's going on. And from there, they share ideas about, okay, I have this problem, I have this challenge, I want to start my sustainability, and there's a whole set of different sensors for them to be able to do so. So, I mean, yeah, we'll open this up here, and for those of you who are interested to visit, you can contact us. Essentially, we host visitors, 2 to 3 visitors every week before we have Python alert. And they get the hands-on. So that's how we are playing our role in terms of helping to overcome this challenge. Yeah.
Yeah. Kenneth, I have one question for you. Do you think it's for a building that already have an existing BMS? Do you find it a challenge to actually onboard what you did?
Not necessarily. First and foremost, the nice part about a building that is already connected together with a traditional building management system is that many of the sensors, if they work, are already interlinked and connected. So in this situation, instead of having to deploy physical sensors, we simply interface with the building management system through a plug-and-play connectivity and map out the data that is important to feed an AI engine, for example, okay? And then use these data sets to make decisions, after which we can command the building management system to make operational changes, operation set point changes to the building itself. So in such a scenario, you can think of what we do is adding a layer of intelligence on top of something that's already there and using data sets to make that intelligent. Because the commodity that we're dealing with is actually data. Okay, so we're not too fussy about having to install new sensors. Of course, the sensors must work, but in order to make smart decisions, in order the whole objective of digitalization is to be able to access data in a simple manner and to use this data to create smart solutions. So we actually kind of like it if you have something that is already integrated. Of course, the caveat is the sensors are working and the data's right. You don't have like temperature showing 90 degrees Celsius kind of thing. Otherwise, that gives you a fast track into using data immediately.
Yeah, so the onboarding should be quite almost immediate, I would say.
Yes, it's very fast. Yeah. So, Farizan, I want to also tap your brains for our audience here. Air conditioning systems, okay? They have the highest energy consumption, as you mentioned earlier. And so those will be a key focus area. How do you see, where do you see opportunities to look at optimizing air conditioning? Now, we all need air cons, right? We can't live without air cons. So we have to live with it. What can we do to optimize energy from air conditioning?
Well, the solution lies, a fair amount of the solution lies in the design, because it's us, it actually depends on us. The way we design, you are the enablers, right? So what we want to control, we will have to let you know. So one of the other ways is actually increasing the temperature by depending, okay, by 1 degrees or depending on the occupant load. So that is just one item, and it depends on the amount of cooling system you're using, the type of cooling system you're using. You're using the typical refrigerant type, or you're using the chilled water type, or depending, you know, there's so many different ones out there. Or you're using a central chiller, etc. But typically, the item that we normally try to control is comfort as well as the occupancy. So the comfort, everybody has their own PMV, or we call medium variation of comfort. You wear a jacket, I just wear this, right? So I will be cold, you will not be. So how do we actually measure, how do we actually control that? That's when we actually need to drive the cooling system to tell us in a very intelligent way to react to that. Okay, and there's another way is, of course, now we have a lot of hybrid cooling. Hybrid cooling is meaning how many times, when do we actually do a cooling versus a ventilation together, coupling the air, the amount of fresh air that you get in the building, now even worse with COVID, the amount of fresh air to intake. You can also use sensors to open and close the dampers. The dampers is the ones that actually control the amount of fresh air that actually goes in. And not just control, you can also monitor the amount of air that actually goes in. You can also do, you can also decouple. For example, you can also do 100% natural ventilation, or you can also close it. Another variations is you can also put in sensors that at certain particulates, at certain temperature, you would like to have the windows open. So the windows will have an actuator, which will again feedback to the control loop and then tells us. So there's many variations to it. It all depends on the type of building, you know, whether you're a community center or you are in a, like what you say, mission critical buildings. Mission critical buildings can be like data centers as sort. And those mission critical buildings, they have set rules, like cannot go beyond certain thresholds. This and this. That is very handy when you have all these IoT sensors and IoT instructions in that box that I mentioned, to actually give them the instruction to control it. Yeah. So I guess that's one of the few benefits, I would say. But I would say that, you know, I think we are lucky, right, Kenneth, that we are in Singapore when it comes to stability of the internet and powerful. Do you think in the future, okay, I'm going to ask you a question that we didn't speak about, that is, what do you think with like 5G and all this internet revolution that's coming out? Do you think there will be actually more burgeoning upcoming? I would like to, you know, pick your mind on the future of it here. How do you, you know, you've been in the line for so long, right? I don't know, I've known you like since, I don't know, like forever. So how do you, you know, crystal ball glaze the future?
Well, I mean, technology moves very quickly, that's for sure. And 5G will enable higher bandwidth and shorter response times. I think people are still thinking about what use cases there will be for 5G. For example, can you do closed loop controls over the internet, over the cloud? How do we have real-time control over different parameters using 5G? Okay, we're talking about navigation, for example, streaming navigation with drones, with autonomous vehicles, that sort of stuff. But if we were to talk a little bit to come back to sustainability, actually a lot of what we do today using LTE networks, for example, is good enough for the use case that we have for sustainability today. So for example, by connecting different sensors together, this is the digitalization piece, right? From multiple locations, we can already immediately enable a facilities manager to manage faults that are happening in other buildings in Singapore or somewhere else, and there is only a 2-second delay between the fault happening on site to what the facility manager sees on his desktop, okay? And within maybe 4 seconds or 5 seconds, depending on the delivery mechanisms, he gets a notification via email or SMS or a voice call with a text-to-speech being played out to him about a fault that's happened. So this is all enabled by communication networks because we need the connectivity to the cloud. And LTE today already gives us this close to near real time, it's 2 seconds. And 5G will probably increase adoption of edge processing. So we'll be able to do much more processing at the edge because we can make changes to how edge processing is done with regards to controls, basically. But I would say that for sustainability purposes, we can do everything that can be done today almost immediately. And we've got many customers now who are integrating and connecting all their buildings together, especially with COVID, because with the work from home, one of the key advantages of digitalization is that you should be able to manage remotely. Okay, you should be able to know what's going on in your environment, so that you can take action even without being physically present. And I think this is going to be important for us moving forward because we are more and more connected, and we don't know when COVID is going to end and when it's going to be the start, hopefully not, of another pandemic. And therefore, this whole work from home thing, in my opinion, is going to continue. And therefore, being able to digitalize the whole real estate environment is going to be very important.
Yeah, I would love to chat with you further, but I think let's just maybe answer some of the question, Kenneth. Give it back to the moderator.
Yeah. So
yeah, hi, Shihor here. So yes, I think we do have a few questions. In fact, some of the question I would say is very down to earth. It's wonderful, you know, we have all this exciting technology, but what does it really mean when it comes to deployment? What kind of a realistic savings, you know, can you share some of that? Like, let's say we implement the lighting, energy, what are they expecting to see in the savings?
Yeah, maybe I'll just take that first. So as I shared earlier, we have implemented intelligent lighting control solutions for a bank, for an education institution, for office spaces, and we have found that the average savings per month, and we're comparing before and after implementation, it's about 30% in terms of energy savings. Okay, and there were some strict criteria that were used for the purpose of this implementation. So firstly, they said, okay, we want to be able to personalize, because some of our employees in certain areas are very fussy. They want certain settings, so they want to personalize. And in the past, if we cannot personalize, then what happens is everything stops. Okay, nobody benefits. So personalization is interesting, and we're talking about how bright the light should be and how long the light should be left on when someone walks away to get a cup of tea, for example. Okay. The second requirement they said was we must your system must never cause employees to wave their hands in order to keep the lights on, and we've seen that a lot, right? So that's another no-no. So they wanted to make sure that this is the case. And then the third criteria was that can save or not. Okay. And so with these three criteria, we've implemented it in several locations, and we've done that by micro zoning. Okay, so instead of like what Farizan said, one switch controls the whole light. Now we have digital switches, okay, which are connected back to the controller, and each zone is a micro zone, and each zone has its own set of sensors, and each zone now can be personalized based on the requirements of the people sitting in that area, depending on what they do. And by doing so, we are very happy to report a 30% savings for energy. And that's a substantial amount for an office space that doesn't pay for air conditioning, because that's included in the rental, right? So lighting becomes a substantial amount. So that's my experience in terms of energy savings.
Yeah, for me it's quite simple, because in our rental buildings, right, one person pays all. So one person, which means the main tenant of the main owner of the building has to pay for the air conditioning and etc. So they do control. So efficiency on that instant is a return directly back to their business. So even more, they should look at the fact that they should enable this so that they can actually control and save more in terms of that. But in terms of savings, right, what Shiha was saying, it was literally, it's around there, I would say 15 to 30%. The reason why there's a range is because it all depends on the building typology. It very much depends on the building typology. And it also very much how much control do we actually put within the particular building. How much control in terms of automation did we put? Of course, the more things we can control, the more we can actually tighten our belt and actually save more. So the less things, then we can't really do much. What I have to say is, I really have to say this, is that the beauty of having the current digitalization that we actually have is that we can work on existing building. You don't have to like, oh, I have no new building, you know, I have an existing building, right? Kind of like, what do I do with my existing building? Can I still put in all these sensors and IoT? Because existing building, there's tons of those existing buildings, and they are the ones who have been built, like it could be 10, 15 years ago, and they don't know what solution they can put on top of that. Correct?
So I think you're talking about retrofitting.
Yeah, retrofitting buildings. That's when it comes in super handy, right? Kind of like you can easily onboard digital or IoT solutions. And that savings is almost immediate. Because you just imagine a building that's built 10 years ago. They don't have smart lighting, as what you were mentioning. They don't have this. They don't have this at all. So they have to enable something that is low-hanging, something that is not disruptive, something that they have already, the DB controller, they have the DB box outside, what can they do? So now with many solutions, I've been to your very nice experience room. So I've seen some of those controllers where you can just literally latched on, right? Kind of, it's just latched on, and then you can actually control for existing or retrofitted buildings. Even if you don't retrofit the building, you just want to control existing building as it is, you can still do it with the IoT. Correct?
Sounds great. And of course, Singapore style, so we all be wondering, so what kind of government support, grants available? Why not, right? So is there some IMDA grant? I'm not sure. Is that already available there?
Yeah, so maybe I will just, since you asked, we'll share this with
I knew you had something up your sleeve for this one.
So there is a grant. It's called the IMDA Advanced Digital Solutions Grant. Okay, and this grant is actually created for people in the built environment to encourage them to digitalize. And the scope of this grant covers anyone who wants to deploy sensors for measuring energy. So that could be circuit-based, smart plugs, and IoT platform. Water. So for some of you, water consumption could be a significant amount, depending on if you're in the food and beverage business, for example. Air quality sensors that Farizan has said has an impact on occupant comfort. Or for that matter, you just want to monitor that your mission critical pump, your mission critical machine is running and you are working from home and you're supposed to be responsible for it, so you can interface with these things. You could also detect occupancy, how many people are in the office, how many people are in a particular area. And the last one is, equipment such as air conditioning. So if you're operating a data center, for example, air conditioning is absolutely mission critical, right? Or your servers will die. So you want to know what's the status of your air conditioning systems, for example, and you want to know whether you can adjust the temperatures if, let's say, a rack becomes too hot or crack unit is down and you want the others to compensate, for example. Then by connecting this together, you can do so. So this is the scope of the IMDA ADS grant. It's basically up to 50,000. They give you up to $50,000 to wire your whole place up. And it includes sensors, the IoT platform, consultancy, and installation works. So we can cover all of these with the 50K grant. And you have literally a choice of a mix of different types of sensors depending on your use case, okay? Because your environments are different. So this is basically the IMDA grant. And for those who are interested to know about it, you can scan the QR code basically, and then you get sent this flyer in detail, and we'd be happy to basically answer any questions you have. Yeah, sure.
Yeah, so keep in mind about timing. So I think we have time for just 2 more questions. So one of it is about, are we seeing that a move towards a SaaS, software as a service kind of pricing model? So, or do you still see a lot of on-premise? Is there sensitivity concern about all this data putting on the cloud? What's your take on that?
We are already providing software as a service in terms of a business model. It's a very good question actually, and we're seeing a very big, I think the world is seeing a trend away from asset ownership, okay? Because they don't want to manage it eventually. You run a business, you need IoT to help you with sustainability, you want to be able to use digitalization, but you don't necessarily want to invest in a lot of people resources to patch your server, for example, put your antivirus in, which is not the aim of what you want to do, right? So software as a service provides 2 main benefits. The first is you don't have to invest in that CapEx, you don't have to invest in the people behind it. The second advantage is you get new versions delivered to you, and we all love that. We love how our apps are updated constantly on our Apple and the Google Play Store. And that means that our investment is always current. There is no old version, there is no legacy system. And I asked a few, I was reading a poll on the US why people like Tesla. And they said, look, Tesla is the only car right now, when I buy it, when I drive for 10 years, I don't get the same thing over and over again. Every week, every month, they introduce some new feature on the screen. I can do something different, my speedometer changes a little bit. And I feel that the car that I own is constantly being renewed, okay, versus what I have right now, which is, it gets outdated. Okay, screen becomes small, for example. This function don't have, that function don't have. So this is one of the advantages of a software as a service model.
Yeah, maybe the last question we have here is perhaps Farizan would like to take this one. The question is about, we have discussed quite a bit about commercial building, commercial spaces, but how about factories, industrial, where you have very high energy load? So what can we do about that?
I actually really like this question. Yeah, I actually really like this question because, I deal with different types of buildings, right? Because the demand-driven load is something that you have the huge savings, where the huge savings are actually coming in from. So what I can tell you to do is actually you have different energy tariffs. I mean, the person who asked these questions has different tariffs, day tariffs, night tariffs, and you also most likely have a carbon tax as well. Because you have cost a certain level. So it's even wiser that you think about your energy strategically. What do you want to use? So for example, the tariffs are different. And if you have, for example, solar energy also, renewable power, you will know when that thing can kick in. when the thing is you're going to use the night load, when are you going to use reserve load to actually run through your buildings? Or sometimes with such a big building, you also run on generator set. I've seen a lot of this. And don't forget, sometimes we also see in production such as agriculture, which there's a few agriculture that we're working on. So agriculture has also a different load levels. So all of these spaces, right, you need the diagnostic. I think Kenneth did mention sometime in his ecosystem that you need the diagnose. So what we do is that we try to diagnose out, we try to pull out where those things are and what we can do to drive a demand-driven load at different tariffs, at different levels, and then put in those sensors, those intelligent sensor to tell the particular machine to use or to drive those particular energy from which source. So it's a very interesting question. I really actually like this question because it means diagnosing further. So yeah, I think you can definitely use any of these IoT sensors. Mind you, because the audience is pretty large when it comes to building spaces, as what I mentioned, the typology is pretty huge. You have factories, you have industrial, and you have all the commercial spaces. But there's a lot more opportunity, I would say, in this person who asked this question.
Yeah, thanks, Farizan. So, in fact, yeah, that will wrap up our panel discussion this piece here. And I think especially I like the point that you have made that, you know, this is not just only for office buildings, right? It's really across, you know, many different sectors. And we also heard from Kenneth, and the solution that you provide, highly configurable. I can see all that. And then it's a very broad coverage. So in fact, this exactly brings back to the original point. We want to have a smart nation, we want a sustainable nation, and these are where the industry pieces that have to come together to make it happen. So with that, I'll pass it back to Christine.
Thank you. Thank you, Shihong. And thank you, Kenneth and Farizan. Okay. Thank you, everyone. So now, before we move on to the survey question, we have a last set of poll questions. Can Song Jie help to bring out the poll question, please? Okay, we'd like to have the audience to help us to improve our webinar. So appreciate that you can provide your feedback to us. So the feedback will be via these last four questions as well as our survey questions. Later on, after this poll question, you can scan the QR code to provide your feedback for the survey question. Thank you very much. So we'll just leave the poll question here as well as the slide for the QR code for the next 5 minutes. So thank you everyone for joining us today. Hope to see you in future webinars.
Thanks, Christine.
All right, thanks, Christine, Shihong, and
Thanks, everyone.
Thanks, Shara. Thanks.
Bye.
Bye.
Bye-bye.